Hello, my name is Connor Kennedy, and today is October 2nd, 2020, and I will be talking to you about the regulation of the gastric phase of digestion. Let's move on. There we go. Alright. So with the stomach is what occurs in the gastric phase of digestion. Primarily focuses, and there are three primary functions of the stomach. We have storage, which is pretty self-explanatory. It stores food. You got digestion. This is where protein and fat digestion begins, and then there is defense, which it protects the body from swallowed pathogens. And the gastric phase itself is integrated with the cephalic, which is before, and the intestinal phase of digestion, which occurs after. So going into more detail about the storage function, we have the receptive relaxation. This is the reflex of the stomach relaxing and expanding as food arrives. And then there's regulation. You have regulation of food, or the stomach choosing when food is ready to be digested, and before moving on to the small intestine. Food sits and in the upper half of the stomach, which then it will move down to the lower half to be digested and turns into chyme. And then it will enter into the small intestine, the first part, which is the duodenum. Next we'll be talking about digestion function. There are many secretions that occur in digestion that occur in the stomach that help with digestion. The first one I'll be talking about is gastrin secretion. First we got G cells, which secrete gastrin and is stimulated by the presence of amino acids and peptides in the stomach and distension. We also see gastrin being released by the gastrin releasing peptides, which is triggered by neural reflexes mediated by enteric nervous system. And gastrin's main function is to promote acid release. Next we have is acid secretion, which leads pretty nicely. We see here that parietal cells secrete hydrochloric acid, also known as gastric acid. Acid causes release and activation of pepsin to digest protein. It also triggers D cells to secrete somatostatin. The acid denatures proteins that allow pepsin to be accessed for digestion, and it also kills bacteria and other microorganisms ingested. It also inactivates the salivary amylase and stops carb digestion that began in the mouth. If we continue on, we got more digestion that occurs, and we'll first talk about enzyme secretion. With enzyme secretion, we have two enzymes that are secreted here in the stomach, and that is pepsin and gastric lipase. Both are secreted by chief cells, but with pepsin, we see chief cells secrete pepsinogen, and then once this pepsinogen has reached the stomach lumen, the pepsinogen becomes active and becomes pepsin. And then once it becomes pepsin, this is when we see protein digestion start to occur. For gastric lipase, like I said, it is co-secreted with pepsin, and for gastric lipase, it is there for digestion of fat by breaking down triglycerides. Next, we'll talk about the pancreas secretion. Here we have a few different secretions that occur. First, we'll see the enterochromaffin-like cells. This secretes histamine. Histamine diffuses to parietal cells to stimulate acid secretion. We have gastric parietal cells that secrete intrinsic factors. The intrinsic factors create complexes with vitamin B12, which is needed for vitamin absorption in the intestine. Then we have D cells that secrete somatostatin. Somatostatin primarily functions as a negative feedback signal for gastric phase in acid secretion. And if we continue on, we have the defense function. So here in the defense function, the stomach secretes mucus and bicarbonate from mucus cells. The mucus forms a physical barrier and bicarbonate to create a chemical buffer barrier underlining the mucus, which is known as the mucus bicarbonate barrier. Here it protects itself from autodigestion by acid and enzymes. And the bicarbonate layer is just above the cell layer as a pH of 7, even though the stomach sits at a pH of about 2. Here's my sources. And that is the end of my presentation. Thank you very much.